In this video, we're going to explore the circumference and area of a circle. Before we do that, though, because we're going to get into some shaded area problems, we want to first look at this warm-up and how do we find the area of this shaded region. So first we want to figure out what exactly do we see going on in this picture. And I see a rectangle and it looks like a triangle or maybe 2 or 3 triangles within there. So the area of the rectangle should be relatively easy to calculate. It's going to be 22 by 12. Which would give us, I gotta use my calculator for this one. All right, 22 times 12 is going to give us 264. Now, the shaded region is the part that doesn't include this triangle in here. So I'm going to take a look at this dimension. I know this is going to be 22, and I know that this has to be 12. So I could find the area of that triangle by using 1/2 base times height. Which is going to give us 132. Now, what I'm going to do is I'm going to take away this rectangle. I'm going to take the rectangle and take away the triangle, and that should give me that shaded area, which just so happens to be half of that rectangle. But the idea is you've got your bigger shape, and then you're taking away what you're not using to get that shaded area. All right, before we get into that, we want to take a look at our area of a circle. And to do that, we're going to look at this little sketch. Oop, there we go. And in this sketch, we have a circle. So we have this circle here up at the top, and then another one down here, same idea. What we're going to do is we're going to peel away layers of the circle. Now the circumference of a circle is 2 times pi times the radius. So we're going to start the show and see what happens with this sketch. We're going to pause it periodically. So when we take away that first layer of the circle is going to be your circumference, because that's basically the perimeter of the circle if you were to walk all the way around it. So we know down here this is going to be 2 pi r. So let's resume and see what happens. So again, we're still peeling away layers and layers. And if you notice that each layer that we're peeling away has a smaller and smaller and smaller and smaller radius. So we're just getting smaller pieces. Now, what ends up happening is it looks like it's forming a triangle. Let's see if it does. And it does. And so the area of the circle, or sorry, the area of the circle is the area of this triangle that's been formed because we've peeled it away into another shape. So we have to figure out what are the dimensions of this circle. Well, again, the area of a triangle is just 1/2 base times height. And the base is the circumference of the circle, and the height is the radius of the circle. And the circumference we know is 2 pi times radius. And so if we take 1/2 of 2 pi, we get 1 pi, and then radius times radius is pi r squared. Now I'm sure you've heard that the area of a circle is pi r squared, but this is why it works out. So now let's apply it. So in problems 1 and 2, we want to find the area and circumference of the circle being described. We're going to leave our answer in terms of pi. We're not going to do any rounding or anything like that. So a circle has a radius of 4. So the area is pi times 4 squared, which is 16 pi. And the circumference is 2 times pi times 4, which is 8 pi. And number 2 is the same type of thing. So if you understood that one, I think you've pretty much got the idea of those types of questions. For number 3, find the area of the shaded region. So we have to think about what's going on here. And what it looks like to me, it kind of looks like a donut or a lifesaver or any kind of shape that has a larger circle and then a smaller circle inside that's been taken away. So what we're going to try and do is find the area of the outer circle. And here we have our center. It looks like it's 6, 4. So if I kind of count away to the edge, 1, 2, 3, it looks like the radius of the bigger circle is going to be 3. And of the smaller circle, looks like 2. So for my outer circle, I'm going to do pi times 3 squared, which is going to be 9 pi. And for the area of the inner circle, pi times 2 squared, which is 4 pi. So the shaded region is the big circle minus your little circle. Subtract them off, and the area is 5 pi. Again, not worried about units because no units were given. In number 4, we have a looks like a rectangle, potentially a square, surrounding a circle. So the process is still the same. We want to find the outer area and then subtract off the inner area. Well, the outer area, we're going to call it this rectangle. It has dimensions 1, 2, 3, 4, 5, 6. 2, 3, 4, 5 by 6. So indeed it is a square. So it's going to be 36. And for the circle, we can start at our center here, which is at negative 5, 5, and we can go kind of straight up to that edge. Now, again, a radius goes from the center to the edge of the circle. So we can't count it this way. We have to go either straight up or down or left or right. So it looks like our radius there is going to be 3. So area of the circle is going to be pi times 3 squared, which is 9 pi. And again, outer shape minus inner shape gives us 36 minus 9 pi. Now, that's all we're going to do. We can't put those together because those are not like terms. One's a whole number, and the other one's in terms of pi. But if you want to double check to make sure you've got it right, you can always use your calculator to verify that you have the correct order. So if we take 36 minus 9 pi, we end up getting, let me go ahead and calculate that. 36 minus 9 pi gives us about 7.2 something, or 7.72 something. If we were to reverse it accidentally, we did 9 pi minus 36, you'd notice that we'd get a negative area, and that can't possibly happen. So it's another nice way for you to double check to make sure your area has been calculated correctly. So this is our final answer. On number 5, it's a little bit different because now we have a circle on the outside and some type of rectangle on the inside. So I think the rectangle is actually going to be easier to calculate. So let's do that. Area of a rectangle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So we don't have a square, which is going to make things a little bit more complicated when we're trying to find the radius. So the area of that is going to be 48. Now to find the radius, we have a number of different ways to do that. And what I'm noticing is if we go from point C to point E, we would actually form what's called the diameter, which goes all the way across the circle, through the center, from one end to the other. But again, it has to hit the circle. So take a look at what we have going on. We have a right triangle with a 6 and an 8, and our hypotenuse here would have to be 10, and that represents the diameter. But the circle is going to be the radius squared times pi. So we have to find half the diameter, which would be 5, and it would give us 25 pi. Again, it looks like 48 is actually bigger than 25 pi, but it's really not, because pi is about 3.14. So if we did 25 times 3, we'd be looking at about 75. So in our final answer, we have 25 pi minus 48. And then I wanted to take a look at the problems down here, because we're basically using the formulas but working backwards. We're given that the area of a circle is 49 pi. So I'm going to write that down. A equals 49 pi. And I also know that equals pi r squared. The circumference is what we're looking for. So to do that, we're going to have to use this formula, 2 pi radius. So looking at the left and the right-hand sides, the pi's are the same on both sides. So I can, if I divide through, they'll cancel out. So I can just kind of cross those off. I've got r squared is 49, so r has to equal 7. So then the circumference is 2 pi times 7, which is 14 pi. And number 8, if I work backwards from the circumference, now we know that 2 pi r is 30 pi. So the pi's, again, cancel out. And so I have 2r equals 30. My radius would be 15. So when I'm finding the area of the circle, I take 15 squared, that's 225. And so it's 225 pi for my answer. So again, area of a circle, pi r squared, circumference of a circle, 2 pi r. We're going to use different applications of those formulas to calculate the area and circumference.